Morning. Let's quickly recapitulate what we have seen last time. Yeah. We have seen resistors. We saw that flip-flop. This flip-flop is able to say only one bit, depending on it activates on edge of the clock, isn't it? So it is able to say only one. So say for example, if you want to save n number of bits, you require n number. One bit per flip-flop, one flip-flop, one. Then we saw what are called the resistors. So array of flip-flop, we say it as a resistor. We saw that resistor or a bank of flip-flops. Okay, a flip-flop is a 1-bit resistor, right? So an array of such flip-flops will form a resistor, okay, a bank of flip-flops. And then we saw that resistor, the information can be fed in two ways, right? In serial fashion or in a parallel fashion. And also it can be written in serial fashion and parallel fashion. So depending on that, we may that as a serial input, serial output, serial input, parallel output, parallel input, serial output, and parallel input, parallel output resistors. Okay, so the mechanism which was there for parallel in serial output, we saw that mechanism. Right? That mechanism is more like a resistor. We saw that mechanism. There are two AND gates and one OR gate, so that is more or less like a multiplex. You see, the circuit model is one multiplex. We saw multiplexer. There were two AND gates, and depending on which AND gate is getting active, that input was simply transferred. So the crux or the heart of that selection is nothing but a multiplex. That small two AND gate and OR gate, whenever you find this kind of structure, okay, it's like a 2:1 multiplex and OR combination. Then, so these are the four types of resistors which we have seen. Then a resistor which satisfies all of these requirements. So, for example, a single resistor, n-bit resistor, from which we can take serial input or parallel input. We can give serial input or parallel output. We can say reset the values and everything if it is possible. That resistor is called as a universal resistor. We can construct a universal resistor from using the same kind of structure which we have seen. Okay, so universal resistor is one which satisfies all the requirements, serial, all types of input, all types of output, and so on. So I give you as a homework to find what would be the structure of that. So universal resistor. So universal resistor is one which satisfies all the requirements. So input is serial or parallel, output is serial or parallel, and also there is option to reset or clear or set, make it 0 or make it 1. So if it satisfies all these requirements, okay, it's called as a universal resistor. Okay, so and it has it has selection lines. It has selection lines to decide, or decision lines, which decides in which mode it would be operating in. So let's say for these four kinds of modes, we will require at least two selection lines, right? So 0, 0, 0, 1, 1, 0, and 1, 1. Depending on this, it will be serial in, serial out, and so on. And for 1, 1, it will be parallel in, parallel out, and so on. So if it satisfies all of them, it's called as a universal resistor. Alright, so fine. So now see, these resistors are something like which retains the value. Okay, once we save the value, they will retain indefinitely. They will retain the values as long as the power is on. Now, such kind of as the flip-flops. Now, it not necessarily be the case that we want to retain the same values always. We may need to change the states of the flip-flop depending on the requirement. Say, for example, I want to design a clock. In clock, I am always keeping track of when the 60 count is reached.
So suppose for a clock period is of 1 second. So for 60 seconds I will count it as a 1 minute. For another 60 seconds I will count it as second minute, and so on. So I'll have to keep track of like 1 happens, after that 2 happens, 3 happens, and so on. So it's like a predefined or prescribed number of sequences which happens, or states, a defined number of states which happens. So if such states are happening, or the states of a register, if they are defined, such kind of register bank is called as a counter. Okay. So let's see what are the counters. So what are the counters? So counters are one whose the states. What do you mean by states? The outputs. Okay, the outputs of the flip flop, or the states of the flip flop. I'll say it as a register. So counter is essentially a register. The state of the register takes some predefined or prescribed sequence. Okay, for example, a counter, binary counter, which counts a binary number. What are the states? Let's say it is a 2-bit binary counter. So it would be 0 0. After that, it must be 0 1. If it is an up counter, then it should be 1 0 and 1 1. So this is kind of these states are defined, isn't it? But that wasn't the case with the register, right? Registers were having some predefined number of states. And once we say 1 0, it will retain 1 0 always. Once we say 0 1, it will retain 0 1 always. But in counters, they change the states in some predefined way. Okay, so here the predefined way is like a up counting. It may be down counting. It may be decimal counting. It may be any count. Okay, so such kind of registers which take some predefined number of states are called as counters. Okay, so counters are essentially registers which take some predefined number of sequences or steps. All right. So let me first put down some points. First is like so how did we begin? We began with actually gates. From gates we have constructed latches. From latches we have constructed flip flops. From flip flops we have constructed registers. Now from registers we are going to construct counters. So basically a flip flop, as I will say, let me write some points. So first, a flip flop is a 1-bit or a single bit memory, right? So for n number of flip flops, you will require n number of, so and saves, so n flip flops Alright, a flip flop is also called as a bistable multivibrator. Okay, now I will put some technical words. A flip flop is also called as Why it is so? Because just because it takes only 2 states. Okay. Now see, whenever I am saying that we will be using the flip flops, mind it, I mean we won't be using those indeterminate states. Okay. Always remember, we'll be setting the flip flop, we'll be resetting, we'll be either saving 1 or 0, or we'll retain the same values. The indefinite state, okay, we are not going to use that. Never use those states. Okay. We are either saving 1 bit as 1 or 0. Okay, we are not going to have those indeterminate state. That is like a unstable situation. We don't want, that is most unwanted situation, and we are not going to use that. Okay, we'll always make sure that the circuit doesn't go into that indeterminate state. So it is also called as a bistable multivibrator, just because two stable states. One and 0. Set or reset. Done. So this is one flip flop, right? So for n number of flip flops, it can have how many number of states? So n number of flip flops, you tell me. N flip flops, tell me. Can have how many number of states? Let's say 2 flip flops. How many number of states are possible? 4, and so on. So 2 to the power n number of states, right? What do you mean by states? The condition, is it set or reset? Okay, for of individual flip flop. A flip flop. Okay, so which are those states? Which are those states from 0 to? Tell me. For one flip flop it is 0 and 1. For two flip flops it is 0, 1, 2 and 3. For three flip flops it is from 0, 1, 2, 3, 4, 5, 6, 7, right? So it doesn't reach 8. So it is 0 to 2 to the power. Is that okay? Therefore, a counter is one. Okay, a counter is one which actually goes through all these sequences including 0. Okay, so which counts. Say for example, if it is a that is also called as, you know, a mod of a resistor, okay, or counter, you can say. So let me write the total number of states a resistor or a bank of flip flops you can say it's a counter. Counter is essentially a resistor, as I said, you know, which is made to operate in predefined number of sequence. A counter, it's of resistor, is called as a modulus of that counter, you can say. Okay, I should write this. The important point here is including 0, right? Should not leave that 0. It's called as a modulus. M of a counter. Is that okay? So for example, if there are 2 flip flops, what mod is it? 4, isn't it? So it is mod 4 type of counters. Okay, so it is nothing but the total number of states we can have. That's how. Now then again, a flip flop is also divide by 2 or a frequency divider, you can say. Frequency divider. let me clarify this. As I am saying that, you consider this waveform, you consider this, a clock signal. Now, flip-flop essentially is a positive edge or a negative edge. That's what we have seen, just because it's a flip-flop. So let's assume it's a negative edge, a flip-flop. Assume that it is a toggle flip-flop. Assume that it is a toggle flip-flop. Okay. State of that would change for every negative pulse or a negative edge. It would change. So assume that it is initially 0. As soon as the negative edge comes, it will turn to be 1. It will toggle, right? It will toggle at each and every negative pulse, right? So for each and every negative pulse, it is called. Now, if this frequency is like f, isn't this half of that f? Because just for every 2 pulses, it is toggling. So that's why it is called as a divide by 2 of. Now that is for only one flip flop, right? Only for one flip flop. For n number of such flip flops, it will be like a frequency will be divided by 2 to the power n, right? So it is a bank of flip flop, okay, or the resistors. You can say it as a 2 to the power n divided by 2 to the power n type of device, okay, or frequency divider, okay. So let's go ahead. So is that clear? Frequency divider. Fine. Next. Now, all right. So the last point I missed was, okay, let's assume, let's go for the next. Now, as I said, a counter is something which counts or has some predefined number of sequence. Now, it may happen that now the number of flip flops, it depends on how many number of counts you want. Say for example, you want maximum 4 counts, will require 2 flip flops and so on. So number of, say for example, there are 6. If you want to count till 6, how many flip flops are required? Oh, at least you should say 3 flip flops, right? I mean, although we won't be using the 7th state, okay, although we won't be using like so say for example it is a mod 6 counter. Mod 6 means it should count 6 states including 0. That means from 0 to 5. Okay, so to count from 0 to 5, okay, till 4 it's okay. I mean, we can manage to with 2 flip flop, but for for has to have 5th count, okay, or the 5th 6th count or 5, we must have the 3rd flip flop, right? So it will be basically log 2 of the number of states m. That is nothing but the number of flip flops m. So these are the total number of flip flops. So the total number of flip flops will always be. Now this is the now I should not say this, but seal of that, isn't it? But because that may be a fractional value, because m may be 6, so log 2 of 6 may be a fractional value, 2 point something. So of course this should be seal of that. So or 2 to the power n should be equals to m. M is nothing but a mod. Modulus is nothing but a number of states it can have, right, including 0. Alright. So let's try. Now again, the counters are, as I said, are formed using resistors. Resistors, as we have seen, that can be formed using any flip flop, isn't it? We can use D flip flop, we can use T flip flop, JK flip flop. We have seen that how to use them. So basically, now similarly, the counters can be constructed using any flip flops operating in complementing mode. Okay, counters can be designed using any flip flop operating in complementary mode. What does it mean? It should always toggle. Okay, it should always toggle. As soon as a pulse comes, it should toggle. So if such kind of, if we are able to construct such kind of structure, that can very well be used for counters. So what is the simplest possible flip-flop which always toggles? It is a T flip-flop, right? So T flip-flop can be used. So T flip-flop we can use. Then what about D flip-flop? Can we use that? D flip-flop, as I said, any flip-flop can be used. How to use D flip-flop? How to make D flip-flop to toggle? Can you think of it? A D flip-flop, how we can think of it as a toggle? Okay, let's consider the JK flip-flop. You always know that. Okay, JK flip-flop. How can we make it for operating in a toggle mode? Tell me. JK flip-flop कब toggle होता है? हाँ? Close your notebooks. Close your notebooks. Close your notebooks. I'm seeing some blank faces. Close your notebooks. Close your notebooks. In what mode JK flip-flop toggles? What is the JK flip-flop? What is the difference between a flip-flop and latch? Exactly. Is it what this is right? Right? Sure. Huh? How can we construct positive age regarding this? How can we construct negative age regarding this? What if both of the inputs are 1, 1? What happens to these inputs? Are you sure? When is it condition? It's a condition. Huh? Is there a condition for PVC? What is indeterminate form?
When we go to the PV state and we apply the circuit, then the output becomes
Okay. How can we use what is D flip-flop? How can we use it as a toggle? D flip-flop we can use XOR gate to become toggle. What if I don't want to use an XOR gate? What do you mean by synchronous flip-flop? What is the resistor? पैरेलल में कनेक्ट हो connector. How many types of resistors are there? Can we have two different types of resistors in one? How? What is the basic unit which we have used so as to have both parallel for using parallel in and serial out? What is the basic unit we have used? Yes, yourself. What is the basic unit which we have used for parallel in and serial out? And how we have constructed parallel in and serial out? Yes. What is that structure said? Yes, sir. Just before that. No, behind you. Yeah, Aman. Yeah. Tell me. Huh? We have used a specific structure. Okay, we have already seen that structure earlier. What is that structure say? You know that? Yes. Are you aware that we have used 2:1 marks? जाग जाओ. JK flip flop in toggle mode. How can we use that? Anyone? Yes. How can we use JK flip flop in toggle mode? Wait, don't. Just be silent. How can we use JK flip flop in toggle mode? Yes, please. How can we use JK flip flop in toggle mode? What's so special about JK flip flop? Yes, yes. पूछ लिया. JK flip flop. What's so special about JK? What is special about JK flip flop? Oh, good. Very good. So JK flip flop in complementing mode. Yes, tell me. Yes, we can use JK flip flop as a complementary mode if we short J and K input. That means if you give always 1, I mean shorting and giving 1. If you make both of them J and K equal to 1, then we can always use it as a toggle flip flop. How did we use D flip flop as a complementing flip flop? Who is here? Yes, please tell me. D flip flop as a complementary flip flop. How can we make it use as a toggle flip flop? Yes, yourself. How can we make use D flip flop as a T flip flop? Yes. अभी आंसर बताया इन्होंने. How? XOR gate. We can use D flip flop either by using XOR gate, or we can simply connect the complementary output to the input. As simple as that. So simply connect. Isn't that? I mean, assuming that it takes only 1 or 0. Okay? It takes only 1 or 0. I mean, the flip flop is never in indeterminate form. Okay? Fine. Let's go ahead. You can open your notebooks. Jago. Okay. All right. So the point to note is, like, these flip flops. We can construct a counter out of a complementary version of any flip flop, and once we have that complementary version, we can use structures something like this. Okay, counters. Okay, there are two types of counters. One is like asynchronous counters, also called as a ripple counter. Another is synchronous. In asynchronous, the output of previous flip flop forms the clock of the next. That means all the flip flops are not triggered at the same time. In synchronous, all the flip flops are actually triggered at the same time. As we have seen in the registers, all of them are having the same clock, right? One clock has been put at the one clock is there for all the flip flops. Same clock is applied to all the flip flops, right? Such kind of structure is called as a synchronous structure, where all of them happen to operate, or the states change at the same time. That is not the case with the asynchronous. Asynchronous depends on there is a ripple. That means first flip-flop gets triggered, then consecutive to that or next flip-flop gets triggered depending on the output of the first, and so on. So such kind of arrangement is called as a asynchronous. So in synchronous we have all at the same time, or we can see it as simultaneously. You can say. So there is no connection, this is this one, and there is no connection. Okay, there is no connection of output of previous and the clock of next. Just because clock is been driven all at the same time, there is no connection of the clock and the input. Okay, so there is no connection of that. Output of previous flip-flop and clock of next. What I am saying is the output, see, the structure will be something like this. ये क्या होना चाहिए, ये डब्बे क्या है, बोलो कौन सा, मतलब what kind of, what is structure, what is there inside this? Now I am saying that it's a counter, okay, 2-bit counter or a mod 4 counter, okay. तो दो फ्लिप फ्लॉप्स है. अब ये दो फ्लिप फ्लॉप्स किस मोड में ऑपरेट करने हैं हमको, कॉम्प्लीमेंट्री मोड में. दैट मीन्स व्हाट, वी कैन यूज टी फ्लिप फ्लॉप, वी कैन यूज डी फ्लिप फ्लॉप, वी कैन यूज जेके फ्लिप फ्लॉप. लेट्स अज्यूम टी फ्लिप फ्लॉप, ओके, वेरी सिंपल केस. So in T flip flop, okay, what do we have? There is a one input T, okay. We have Q and Q bar. Here also T, Q and Q bar. Is that okay? There is a clock. बोलो कौन सा एज है ये? Positive age. What we have derived, okay, using latches, this is a negative age. Okay, let's assume a negative age flip flop. Okay, we can go for positive age also, no problem. Assume it as a negative age flip flop. Input, okay, so as to make it happen as a toggle flip flop, where should I connect this? When is it toggling? When the input is, when does the T flip flop toggles? Yes, anyone? लैब में एक्सपेरिमेंट किए. When does the T flip flop toggles? If the output of a T flip flop is 0 and if I give input T as 0, what is the next state? What if the output of a T flip flop is 1 and if I give 0, what is the next state? What if the current state is 0 and if I give input as 0, what is the next state? What if the output is 1 and the input is 0, what is the next state? What if the output is 1 and input is 1, what is the next state? When the previous state is 1 and the input is 1, what is the next state? हे भगवान बच्चों देखो, T flip flop, it toggles. When does it toggle? When the input is 1. Unless and otherwise it won't toggle. If it is 0, it will retain whatever is the previous state. So what I am asking, if the previous state is 0 and if I give 0, what is the next state? Of course it is going to 0. Doesn't matter what is the previous state. If the input is 0, it will retain the state. If the state is 0 or 1, it will retain the same state as long as the input is 0. It will toggle, okay, the state, the previous state, when the input is 1. Don't you know that? Why wrong answers then? आगे पढ़ाऊँ नहीं पढ़ाऊँ बोलो मुझे। आपको बेसिक्स ही नहीं पता, लैब के एक्सपेरिमेंट्स कर दिए आपने। देखो अभी ये क्लास में ठीक है, नेक्स्ट क्लास में अगर मैं ऐसे क्वेश्चन लूँगा, if in case you are not able to answer, please don't sit in my class, okay? You want full attendance, I'll give full attendance, no problem, okay? If you want, but in lab, okay, lab also you should be able to answer, okay? If you are able to answer, then only sit in the lab, otherwise. Again I am saying that, okay, toggle mode, I am saying that an asynchronous or a ripple counter, I am giving the output of 1 to the clock of next, right? Should I connect it like this? The output, now this is a complement. Now it depends on if this is connected and that is connected, you know, the behavior of this, you know, complete circuit is different, okay? So, and what about the clock? Here we'll give some only one clock, right? See here, both of these flip-flops are not driven by the same clock. That's why they are called, this is called as a asynchronous or a ripple, just because, you know, there is a rippling of output from one stage to the other, okay? There is like a jumping of output from one stage to the other, like output of one is triggering the you know, the next flip-flop or a consecutive flip-flop. That's why it's called as a ripple, you know, a ripple counter. Now can you draw a waveform for this? Can you draw a waveform for this? Assume that initial states are 0 0. Assume that initial states are 0 0. Can you draw the waveform for next 4 clock cycles? Do that. Let me see how many of you are able to do that. Shame on you guys. If you don't know these things, really, there is no worth नहीं है आपको पढ़ाना. निकालो वेवफॉर्म, देखता हूँ कितने लोगों का आता है. Assume that initial state is 0 0. Or the other way around.
not proactive in the class, you were not vigilant in the class, you were not attentive in the class.
Now this T is always connected to 1, okay? I am saying that just because this is a toggle 1. Now you draw it. I am saying that the flip-flops should operate in toggle. Of course T should be connected to 1. Class of आप लोग फी कितना पे चले कॉलेज की फी कितना पे चले ठीक है आपका एक्सक्लूडिंग हॉस्टल हाँ पर सेमेस्टर 4,000 पकड़ लो 15,000 रुपये 1,20,000 रुपये और हॉस्टल का जो लोग हॉस्टल में रहते हैं चलो जो लोग हॉस्टल में नहीं रह रहे क्लास पिला कर रहते हैं ना 2 लाख 2 लाख 4 लाख सालाना भर रहे 2 लाख कम से कम These are the expectations. जो करना है करो. All right, I'll directly write it. You tell me, okay. Now this is, let me write as, okay. This is 0 and 1 or, oh sorry, 1 and, I can make it as 0 and 1, okay, logic 1 and logic 0, it depends on me, okay, if it is a positive logic system or a negative logic system. It doesn't matter now, this may be logic 1, okay, that may be 0 or maybe the reverse way around, okay, it depends on it is a positive logic system or negative logic system. See here, both the inputs are connected to 1, 1, okay. I have said that let the initial, the initial value of this 2 flip-flops be 0, 0, Okay. Now when this, let's take flip flop one by one. Okay. Where is the clock applied? पहले flip flop बना. ठीक है. Clock कैसे change हो रहा है? This is how the clock is changing. Okay. It is given. Now this is T flip flop and it will definitely toggle just because the T is connected to 1. When it will toggle? As when the negative edge of the clock appears, right? So negative edge, ना यहाँ पे. It toggles means if it is 0 it will become 1, if it is 1 it will become 0. What is the initial state? It was 0, right? So I am drawing the waveform for this one Q, the first flip flop ka waveform. It will be 0 initially. How long it will be 0? Till the the edge comes, right? Then it will turn to 1. It will retain 1 till the next clock edge comes. It will go to 0. Then it will maintain 0 till again the next negative edge comes, just because it's a negative edge triggered flip flop, and so on. Is that okay? Fine. Now I am drawing this. Now what is this? Now let me write that. This, let's it be Q 0 0 1 1. So it is for Q. What is for Q1? For Q1, now let's consider this. Now again it is in toggling mode, but when it will toggle? When the clock of this flip flop, okay, attains a negative edge, right? So what is the negative edge of this clock? What is the clock for this? You tell me. The output of that, right? The output of previous one. ये ना जो पीले में ड्रॉ किया है, येलो में, ठीक है? तो दिस इसका जब निगेटिव आएगा तब वो टॉगल करेगा, एंड सो ऑन. सो इसका निगेटिव ना यहाँ पे टॉगल करेगा, तब तक कि टॉगल नहीं करेगा. दैट मीन्स इट विल रिटेन द सेम स्टेट. Will retain the same state till this negative edge appears of Q0, isn't it? Again it will retain the same state till the negative edge appears, and so on. Now this is the waveform for Q1. Can you see what is the behavior of this? As I said, a flip flop is a frequency divider. See, what is the frequency? If it is 10 Hertz, it will be 5 Hertz. If it is 5 Hertz here, it will be 2.5 Hertz, and so on, isn't it? For every 4 pulses, there is a 1 pulse here. For every 2 pulses, there is a pulse here, and so on. So every flip flop is acting as a divide by 2, frequency divider, isn't it? So this is how the now see what is the pattern it is getting. Okay, see what is the pattern. Now you consider when the clock appears here, ना ये वाला ना, देखो pattern क्या है, ये 0 है, ये initially it is 0 0, right? It is 0 1 here. What is the pattern here? It is 0 and here 1, right? So the 1 remains here. So let me write it as only. So it is 0 0 here. It is 0 1 here. What about this? 1 0 here, 1 1. Can you see the pattern? I mean, this is Q1, no? So it is Q1 and Q0. They are taking the states as 0 0, then 0 1 1 0 1 1. Isn't that a counting which is happening? I mean, this kind of structure is taking some predefined format or predefined sequence or predefined states. Of course, it's a counter. All the counts, okay, all the states are not changing at the same time. That's why it's a ripple or asynchronous counter. It is changing the states, okay, depending on the it's counting in binary. So it's a binary counter. So that's why it is and it is counting 2 bits, right? So it's a 2-bit asynchronous counter, right? Asynchronous, but what age? Negative age. So let me write the full name of this. So what is the full name of this? So it's become 2-bit. Now also it is up counting, isn't it? It is up counting, isn't it? It's counting. Now it's not necessary to count it in an incrementing format or increasing order. It may be down counting also. It's a 2-bit asynchronous binary up counter, or you can always say it as a mod. बोलो mod क्या आएगा? Mod 4 using T flip. Is that okay? Now try connecting Q0 bar to the the clock of the next. Okay, and take the output from the same end. Okay, take the output from Q0 and Q1, but the clock of the next flip flop should be taken from the Q0 bar. Okay, can you simply modify? I mean, what I'm saying is you simply modify this structure something like this. Okay, and take the output from here and here. Tell me what is the output. Draw the waveforms for that. Quick. Right. Take the address. Anyone? What the waveform? Yeah, what is it like? What is it like? Can you check the output? Can you see the behavior of the output? What is the behavior of the output? Tell me the full name of that. Tell me the full name of that structure. Yeah, tell me full name. Anyone? None. How many of you got the waveform? What is it like? complementary of previous? Sure. Complementary in what sense? Huh? Hey, complement of what? I mean, complementary means what? The waveforms are complement? Okay, so what is like, I mean, what can we say about the behavior of that, the output of that? If you are right, I mean, nearly. You compare this Q1 and Q0 and note down all the states. What is it like? You note down Q1 and Q0 for each and every transition. What is it like? You tell me the transition states, you tell me. What are the states? Q1 and Q0. Bolo. Initially they are 0, 0. Okay, leave it. After that? After that? Then? Go on. You leave about the previous state. What is it like? 3, 1, 0, right? So it's like a down counter, right? So the full name of this is 2-bit binary asynchronous counter, right? Down counter, isn't it? So this is like a 2-bit, let me write that. Tell me full name of this 2-bit. But what age? 2-bit asynchronous negative age down counter using T flip. That's how you should, everything should be mentioned in the name. Homework for you is to come up with a positive age triggered n bit, or you can take n as anything, okay. Come up with a positive age triggered counter, okay, 3-bit positive age trigger and negative age trigger using T flip flop, D flip flop and JK flip flop, okay. Homework is to come up with 3-bit positive age up and down counter asynchronous using T flip flop, D flip flop and JK flip flop. Is that fine? Draw the waveforms for everything, okay, every other design. Stop here.